Hello friends. So in this lecture I will be showing you and I will be giving information about gates. Okay. So gates are very important. Why they are very important? Because they are building blocks of any digital circuit. Any digital circuits. So before going or before understanding about before understanding about computer organization, it is very important to understand gates. And without understanding the flow of gates, you will not able to understand computer organization. Okay. So there are two types of gates. Okay. Two types. One is basic gates and another is derived gates. It means that basic gates, through combination of these basic gates, we can assemble gates which are known as derived gates. So what are basic gates and or and not are termed as basic gates. And what are derived gates? It is NAND, NOR, XOR. So these are derived gates. Okay. So let us understand. Okay. So it is very important to understand if anybody is asking about gates, then you have to provide three kinds of information. First is logical diagram. Okay. Second is logical symbol. Okay. And very important is truth table. Okay, what is truth? First of all, let me give you. So as I have said you that we have three basic gates. One is AND, another is OR, and next one is NOT. So what is logical symbol of this gate? So it is termed as this A, B, C. It means it has two input and one output. Okay, two input and one output. Okay, 2 input and 1 output. Let me draw very clearly. So this is a symbol of AND gate, AND gate in the form of D. So it has 2 input, number of input equals to 2, and number of output equals to 1. Okay, so A and B are inputs and C is output. Okay, so how it can be symbolized as A and B. Whenever you see that there is a dot mark between two alphabets, then you can easily identify that this is a symbol of AND gate. Okay, so see, there are number of how many inputs? There are 2 inputs. So for 2 inputs, number of combinations. What do you mean by number of combinations? Suppose that you have two letters, 2 integers, 5 and 7. So how many letters how many letters can be formed? 5 7, 7 5, 5 5 and 7 7. It means these two numbers, if we form a combination of these two numbers, then 4 individual and distinct integers can be formed. Okay, so what is number of combinations? There is a formula for number of combinations. So for number of combinations equals to 2 to the power n. And what is n? N equals to number of inputs. So what is here? Number of input equals to 2. Therefore number of combinations will be 2 to the power 2. It means 4. It means for this AND gate we have 4 combinations. Okay, so as we all know that there are only 2 signals, zeros and 1 for any of the digital circuit, so we have to consider only these 2. Okay, so there are four combinations. So what we will do for, okay, this is the total number of combinations. So first of all, you just half it. Total number will be 2. So okay, just start from 0 0 0 0 1 1, 2 zeros and 2 1, and from this 2 just half it, 0 1 0 1. So okay, this is the combination 0 0 0 1 1 0 1 1. So this is just like multiplication. You can assume it just like multiplication. So anything multiplied by 0 will be 0. So what is this? This is truth table. What is this? This is truth table. Truth table of AND gate. What does this mean? Suppose that we pick this combination. It means if input of A is 1, and input of B is 0, then what is the combination? What should be the output? Output should be 0. Okay. So this is okay. If input is 0 and 1, what should be the combination? Combination will be, output will be 0. Okay, so in this way we can define AND gate. Okay, coming on to OR gate. Okay, so coming on to OR gate. So OR gate looks like this: A, B and C. See, number of combinations, number of input A, B, and what is the output is C. Okay, so number of combination will be 0 0 1 1 0 1 and 0 1. Again the same formula applies here. Number of combination equals to number of combinations equals to 2 to the power n. Number of combination equals to 2 to the power n. It means 2 to the power 2 equals to 4. So we have written here 1 2 3 4. There are 4 combinations. Okay, and what is the equation? What should be the equation? C equals to A plus B. So this is not addition, but this is a kind of symbol of OR gate. This is OR gate. Okay, so anything, just assume in the firstly just assume that if anything added with 0, result will be 0. If anything added with if anything added with 1, result will always be 1. If anything added with 1, result will always be 1, and if anything added with 1, result will always be 1. So this is the truth table for OR gate. It means, suppose that if you pick this combination, so if A equals to 1, input of A equals to 1 and input of B equals to 0, result will be what? A and 0 will be what? 1. Okay, so this is all about what? This is all about OR gate. Okay. Next one is very easy. It is NOT gate. It is sometimes it is called as inverter. Sometimes this is called as inverter. It has number of input equals to 1, and number of output equals to 1. It means number of input equals to 1 and number of output equals to 1. See, here it is bubble. If anything comes from here, so number of combinations equals to 2 to the power n. And what is n? Number of input equals to 1. So 2 to the power 1 equals to 2. It means we have only 2 inputs. So if anything comes from here, if 0 is coming from here as an input, so result will, what will happen? After crossing this bubble, it will change to 1. If we apply input as 1, after crossing this bubble, the result will be what? It will change to 0. So what is this? This is NOT gate. Okay, and what is this? This is OR gate. Okay, so I think you have understood. So A dot B is AND, A plus B is OR, and A bar is NOT. So this is the representation by which we can represent our basic gates, and I think you have understood about truth table. These are truth table, very important. Without truth table you can't able to analyze, or you can't able to produce the results. So this is very important to understand number of combinations and truth table. So thanks for watching my video.